Hello, welcome to the ASME Dynamic Systems and Control Division podcast series. Before we get started, I want to remind everyone to please subscribe to our YouTube channel so that you can get the latest updates on new episodes.
Hello, this is ASME Dynamic Systems Control Division podcast series. I'm host Yao Ma from Texas Tech University. In today's episode, we are glad to invite Professor Stephanie Stockar from The Ohio State University as our guest. So welcome, Stephanie. Do you mind start with the self-introduction?
Sure. First off, thank you so much for inviting me as one of the guests on this podcast series. I've seen the list of speakers and guests before, and it's quite impressive. So thank you for the honor of having me. As Yao mentioned, my name is Stephanie Stockar, and I'm an assistant professor in the Department of Mechanical and Aerospace Engineering at The Ohio State University. I have all my degrees in mechanical engineering, so it's got quite interesting situation because I do a lot of optimization and control, but still my background is in mechanical engineering. Before joining Ohio State, I was an assistant professor at Penn State, also in the Department of Mechanical Engineering. And before then, I did a postdoc at the Center for Automotive Research and got my PhD from Ohio State, got my bachelor and master degree from the ETH in Switzerland. Right now, I am working on the optimization and control of energy systems. And I think that's it.
Yeah, thank you again for taking the time and joining us for a discussion. And just in case for our new audience, give some background about this podcast series. So I launched this series to interview researchers, students, and all other members from our community, trying to facilitate better communication and build a closer community. And so that being said, let me start this interview with first, congratulations on your very recent NSF Career Award. Can you share with us what this project is about and how you developed the idea from the beginning?
Sure, we are very happy to. So I'm quite excited, as you said, it's pretty recent. So it's a good place to be right now. The project is in the area, as I mentioned, of optimization and control. Specifically, it's focusing on partial differential equations. So we're looking at constraint optimal control of partial differential equations for applications related to transportation, sustainability, energy distribution, and energy conversion. So the idea is that many of the important processes in energy storage, energy conversion, energy distribution are described by partial differential equations. As I did in my PhD, we started off by studying model order reductions for partial differential equations so that we could apply control and optimization techniques. So that's where I came from originally. So I was doing a lot of model order reduction and modeling for this sort of systems. On the other hand, I was also working on optimization and control of thermal fluid systems. And those systems are getting more and more complicated, so are getting larger and larger scale. We're also looking at autonomous vehicles. So we're looking at very large scale systems. So the question was, what if instead of reducing the system, we're actually tackling the PDE first and then reduce eventually the control for actual application. So that was kind of like the shift in the approach that was the core of the proposal.
So basically, you're saying that originally you're starting from the model reduction perspective to simplify the problem a little bit, but now this new project is directly taking from the root of the foundational PDE control first, and then trying to apply on this.
So I can give you an example. So for engine control, for example, right? Engine control-oriented models is typically based on a one-state model, and then you calibrate a parameter so that you hide all the effects of the gas dynamic, which is a partial differential equation describing waves. Right. So during my PhD, we decided to investigate whether there were methods for actually capturing this distributed effect in a control-oriented method. And so hence model order reduction, right? It worked great. We came up with some good methodologies. The results were good. but we ended up with a system that had a lot of states.
Right.
So we reduced from infinite to, let's say, 70, right? So it was reduced, but it was still too high order for actually doing online control. It was a great method for doing HIL. There was a lot of things like computational speed was great, but it was still high order. So the next step would have been reducing it further, right? So at some point you ask yourself, when do I need to stop? Because when the model is still good enough and when you're introducing too much approximation. So as we did for my PhD, where we said, well, we are hiding too many things in this calibration parameter. Let's try to start with the PDE and reduce the PDE. This NSF proposal follow kind of the same idea of, we need to stop reducing this planned model, because at some point, where do we stop? And so I started looking at the PDE. And another hypothesis that we put forward with this proposal is, sometimes we have these large scale systems such as multi-agent systems, so like platoons or UAVs. So lots of different agents together. And right now we're interpreting them as a large scale system that are interacting with each other and so on. But again, would it make sense to look at a distributed approach for those systems, meaning like continuum approach for those systems, like looking at them as PDEs maybe, and then design the control as a PDE system and then eventually move. So that this is the premise of this proposal, and we'll see. As you said, it's pretty recent, so.
It was very challenging because I was thinking about this because you need to come up with a theoretical framework for the PDE control first, and then implementing the real-time control probably at the end of the project too.
Yeah, so we are definitely looking at two different type of problems. For PDE, you have boundary control and you have discrete field control. So you can control basically one end of your domain, or you can control throughout the domain. And mathematically, as you said, it's very difficult and very different. So we're starting exploring these things. So
so among all those things, what are, or if there are any challenges you encountered when you are trying to developing this project, from the, let's say, initial conceptualization, preliminary studies, and to the final, probably putting everything together, writing the proposal, right? So if so, how did you overcome these challenges?
Right, that's a great question. I think anybody that ever tried to write a grant or a proposal went through, the technical challenge of, going through, okay, this is identifying the issue, identify the limitation of the state of the art, and then coming up with maybe a possible solution approach. The technical part is it's very project specific. I think you hit a roadblock at some point and you're hoping for the best. What was really unique about, I think, the career writing was that it's not a simple grant. First off, it's your idea, it's your background. So it's not like you're applying for a specific grant on a specific subject, right? You can propose anything. So that lack of constraint is somehow, at some point, it gets scary, right? So where do you draw the boundaries of this proposal? And then to me, it was an interesting experience because, again, it started from a place where I was thinking, well, where do you go from now? And then I thought, oh, we can look at this in a completely different way. I was actually working at a slightly different subject for my career. And then I got to the point, it was like, I don't like where this research is going. I don't see it. And so I decided to completely flip the way that we were approaching the problem. It was the same problem, really, but so I went through that process. And then for me, the interesting part, the part where I really relied on my support mechanism at home was the proposal writing. It's a very introspective experience when you have to write your career proposal. You need to think about not just the fact that this is exciting research, but how does it fit with what you want to do as a grown-up? And how does it fit with your educational goals? How does it fit with the community in general? And how does it fit with the university you're in, right? How can you make an impact with your research in the position that you are right now. And so it's a lot of questions. There are a lot of, you know, self-reflecting moments throughout this this process. And also it's a very, I thought it was a very interesting like learning experience for about like myself. I knew that I had some, you know, when I write things, I know my shortcomings when I write things, right? So, and so I think I went through this roller coaster of emotion going through like last summer writing and then rewriting some sections, and like the first draft of the career never left my computer. I looked at it, I was like, oh, that's rough. So I think, you know, like mentally sticking with it and just push through. And then, you know, the second version, you look at it and you're like, oh, this actually looks, I mean, not nice yet, but like something that I should put some time into. So I think that was, to me, like that was very unique about the career. You know, it's something that you don't train when you write other proposals, because the other proposal is usually more specific, right?
Yeah.
So
yeah, what I'm hearing is a lot of fun and perseverance.
yeah, it was an interesting time. Also, it was during the pandemic, so it was kind of challenging because sometimes you have colleagues that are planning on submitting the career proposal at the same time, so maybe you see them on campus in the department. But last year I was home with the cat looking at the proposals. It's like, it was an interesting time. I don't know, honestly. I think I got lucky that I was forced to, I guess in a way, because I was home, I was able to shut down a lot of things, like like a lot of the advising or like teaching and things like that, like committee. I was not as involved, and I told my student, you guys, I'm sorry, but I really need to write this. And it was just easier to carve out the time that maybe, you know, during a regular summer, I'm seeing this year, during a regular summer, I wouldn't have had the opportunity to. So, you know, on the bright side, I think I made a good use of the working from home situation arrangement.
Right. So as you just mentioned, that this career project is not only about the previous research, it's about what you're doing for at least next couple of years, right? And so for that, moving forward in the next, let's say 5 to 10 years, what do you anticipate to be the most significant outcome, and how do you think it will impact the scientific field and as well as probably the broader society?
Yeah, so as I mentioned, we are targeting really energy distribution, energy storage, energy conversion systems. Specifically in the career proposal, I talked about the automotive and the built environment. So we're looking at transportation systems, and we're looking at energy system and buildings. Those are the big energy consumers right now in our society. And so the hope is that if we find a better way or a more streamlined way to design optimal control that accounts for constraints in states and control inputs and so on, we can actually deploy this technology faster. We can, maybe by bridging the gap between, you know, what our model is and what the system is. So designing the control directly on the PDE, we're maybe able to get better performance. That's the hope. And in general, everything is really done in support of energy conservation and sustainability. So reducing the environmental impact of transportation and building heating, energy usage for heating and cooling, and all those systems.
Right. And from out here, it seems like the foundational, like the constrained PDE optimal control, if it works out, then it can apply to a lot of different applications, and this transportation and the energy storage, as you mentioned. And but like you said, a lot of the flow system can be probably used this method.
Yeah, for sure. I mean, the mathematical framework should work for any PDE. So we're looking at two different classes of PDE. One is hyperbolic and the other one is parabolic. So we're also covering different form of PDEs as well. that have different characteristics. That's important. But as you said, the objective is to keep this methodology as general as possible so that it could be applicable to any system that is described by a PD and has some constraints to be accounted for. So yeah, I think on the specific impact of the theoretical, so the theoretical contribution for sure is in PD control. So hopefully it's a pretty broad field. And in general society, I think energy conservation is the big driver for this work.
Right. And so besides the research, I know that you have been also very effective in mentoring both the undergraduate and graduate students. Several of them have been awarded the NSF Graduate Research Fellowship Program recently, I believe, last year and this year, right?
Yeah, that is correct.
So can you share some of your experience in working with the students and give some tips probably for the prospective students as well?
So I have to say, full disclosure, that I was almost when I got the notification from my student, because you don't get the notification if your student get a GRFP, they get it and then they tell you. So they told me that they got it and I was so proud. So I was very excited. So I would say that I was just as happy as when I saw that I got the career award. I mean, maybe, comparable, different type of happy. I was like, I felt like a proud advisor in that moment. But yeah, so I've been involved with undergraduate research. That's also a big portion of my career proposal, outreach and educational plan. I had the great opportunity both at Penn State and Ohio State to work with undergrad students, they were doing research during that time. And it's been just so great to see them, go from undergrad students, started, exploring a little bit of research activities, and then decide to pursue graduate education, and then put together their first proposal as a GRFP applicants and have this discussion about research with them and help them shape this proposal, making sure they have all their components in place, and then see that award. That's just a great experience. So obviously I had the privilege of working with outstanding students. So that's the first thing. These students are just amazing students, but are amazing human beings. And I think that's what really helped the success rate so far, that they're not just great students. It's not just you have your 4.0 GPA. It's like what you do to get there, the challenges that you have to overcome to get there, and what do you do when you're not actually in school. So what do you do on the side? What makes you a well-rounded person, right? And so I was lucky enough so that my students are, have lots of interest outside of engineering. They have interesting stories, and they're just, great people, great humans. So it was an easy task on my side. And for sure, I mean, you need to talk to them and help them, because again, that's their first proposal. So I think my feedback was mostly on making sure, as I mentioned, that they had all the pieces of the application. Is just not just the research idea, but their impact, and at the end of their graduate studies, why it matters, right? What impact will they make as engineers, as leader in their field? Why this research is important, but also why they're uniquely positioned to make a difference. So that's how we usually structure the application. But again, I have to say that they made my job particularly easy. So
yeah, I'm sure this is going to be a joint effort from both the advisor and the students. Look forward for your more students' success stories.
Oh yeah, I'm just sitting and watching it. I mean, I'm advising, but I mean, it's quite. I'm also looking forward to seeing their career.
Absolutely.
Very promising. So.
So we've talked about the research and education. among many other activities I'm sure you're occupied with. So how do you balance the workload to maintain the productivity? You've been extremely productive even during this challenging time. So share with us some of your tips.
So I'm laughing because yes, I have to quote one of my colleagues. We were at the panel when we still had in-person conferences, right? And it was a panel about, I don't remember, it was a career panel, not career, like not NSF career panel, like career panel, like lowercase career. And somebody asked, and I think it was like young, like graduating PhD students and talking to young faculty, and they asked the question about how do you balance, and he said something on the line of, well, when you're a first year assistant professor, you don't balance your job and your personal life. You're balancing research, education, research, teaching, and services. That's the balancing. That's the juggling job. And so I think I'm in a point in my career where I'm a little past that. So I think that I am now looking at balancing different things. And I agree with you. It was extremely important during the pandemic to have a good support system and stuff that I was doing outside of work, because during this year and a half that we've been working from home, I'm back in the office now for my own sanity, but it was very difficult to decide when the workday was over, right? Like, oh, it's 9 p.m., but I guess, the office is here. Why,
Right.
why stopping? So I think that having some interest outside of work was really important. And I was lucky enough that my passions were stuff that I could still do during the pandemic, because so funny little background story, as I mentioned, I'm originally from Switzerland. And so my passions are mountains, sports, so hiking, skiing, anything that has to do with staying outside and enjoy mountains and lakes. And of course, I live in Ohio, so that has proven a challenge. So a few years ago, yeah, it's pretty flat. I still remember when I landed the first time. We were approaching Columbus Airport. I looked around, I was like, wow, that is remarkably flat.
Yeah.
I've never seen anything like it. So, but anyway, so a few years ago, I decided that I still wanted to spend time outside, also because I still ski, I still go hiking, but it's just like a few times a year now when we travel either west or we go back to Europe. So fortunately, my husband shared my passion for skiing and the cold weather in the mountains. So we share that passion. And so we realized that we needed to find something to do in Ohio that will actually help when we go out in Colorado and decide to hike a mountain, so that we're in decent shape. And so I started, now it's on record. I started doing long distance running. I signed up for a half marathon a few years ago. I think now 6 years ago. I ran my first half marathon. It was an awful experience. I hated every single minute of that. And so I signed up again because, it's kind of like when you write your career, you write your first one, you're like, oh, this is awful. Let's write it again. So I like my first draft of the career was kind of like my first half marathon. I was like, not my best work. I think I'm getting somewhere. I think I can do better. So I ran again. And then I started doing marathons. And then lately I've upgraded to, or I don't know if it's an upgrade or a poor life choice. Either way, I started doing ultra marathons, like ultra trails. So I spent the last one, over the past 12 months, I ran 2 50-milers. So I stayed out, a long time. The last one was in Bryce Canyon, and it was a lot of elevation gain, lots of sand. It was gross. It took me forever. And so that's kind of what I do. And, to get there, you cannot just show up, you have to train. So I spend a lot of time, well, not a lot of time, spend a good portion of my free time, or what I carve out to be my free time, running and hiking. It's been great. It's been a great experience. I mean, Columbus has a great running community, has a great trail running community, surprisingly enough. So we we made friends over the past few years with people that have absolutely nothing to do with the university. They don't do research. They are not even probably, I mean, some of them are not even engineers, right? And so it's a great, especially the trail running community is a very supportive community. You travel around, you help people out. So it's a great environment, great environment to be around. And then mentally, I think that this long distance running really helped me in my work. So the running helped me because, keep sanity. But also I learned so much about, they always tell you, run the mile you're in. And I thought that was very helpful for me because even like on a professional standpoint, because I'm always thinking, oh, 3 years from now, 5 years from now, but you need to figure out what you need to do now to get there, right? Sometimes I skip ahead. And so run the mile you're in was always a good suggestion that I got. And I never got it, like I never applied to my professional life until I ran my first marathon. And I was like, well, that makes sense now because I'm like halfway through. I cannot think about what's going to happen on mile 20 because I need to get to mile 20. So that was it was a random thing that I started doing, but turned out to be very helpful again to balance out my free time and also to spend time with interesting and really awesome people. So that was great. We like food, so that's another good reason why I started running. It's like, well, the food scene in Columbus is quite interesting and dangerous, so started running because of that. So
we learn from this. It sounds like you have chosen a very challenging hobby, and and
you will be surprised. You will be surprised, but many people that you find doing these crazy races of like 100-milers in the mountains for 48 hours cutoff times, they have very challenging jobs. Like they have their engineers, their professors. It's not like, it's something that it's income. Like many people that have stressful jobs find very, very soothing. I guess, you're out there, you're on your own. You don't really have a cell phone, or if you have, I mean, you're running, so you should not check your emails. So, but it's been great. Like it's been a great, mostly mental challenge, especially when you go up with those type of distances. Like a marathon is still a very physical challenge, I think. I found it, but the moment that you go trail running like over 50 kilometers, that's kind of weird, where you balance out your mental strength with your physical. So it's a mental game. So it's very, very similar to our job, I think. So
yeah, exactly. I mean, I was just going to say that, go back to our original talking point, that it sounds very fun and a lot of perseverance.
Yes, it does. Yeah, I guess I found a hobby that doesn't stray too far from my job. So exactly. Well, it's a kind of a good sign. I think it's just I like the type of activity that requires a lot of, I guess, perseverance. But yeah, no, it was yeah. And again, I was lucky because we could still go out running throughout the pandemic. So we were able to meet with our friends outside. So we had the opportunity to see other people, not in Zoom. And right. So that really was so helpful to go through this whole process. I haven't seen my students in a year almost, right? Because we were all working from home. So that was really challenging. You worry, you don't know how things are going. And so, but yeah, now we're back in the office. So everything, it seems to be going slowly back to normal. I'm right. Still running, not so much now, but we started ramping up other things and spending time with the students and on campus finally. But was a interesting couple of, well, year and a half, more than a year and a half, and I don't think now we are still 100% back to normal, but we'll see.
Sounds great. Again, thank you very much for joining us today, and it was a great time to talk with you, and I look forward to see more exciting news from your group.
Thank you so much. It was great, great chatting with you. Hopefully, the listener will also have fun and have a great one.